Hello and welcome to our lesson on compound interest. So compound interest is another common way that we can either charge interest, remember interest is a fee, so we can charge interest on a loan or we can earn interest on an investment. So compound interest is another way to charge that fee if you're borrowing money or to earn that fee. That fee is paid to you if you have some investment on your money. Now with simple interest, if you recall, the interest is calculated one time over the course of your loan or your investment. With compound interest, the interest is going to be calculated several times depending on the terms of your loan or your investment. So it generally won't be once because that would be simple interest. It's generally going to be, we can say, daily, weekly, monthly, quarterly, semi-annually, and we'll talk more about those words in a little bit, but multiple times throughout the year, okay? Now, what happens then is the interest that's being accrued, and remember that's the word for, or the word that encompasses charging and earning. So that interest that is accrued is added to the principal balance before you calculate the interest again. So simple interest is like a one-time shot. Compound interest is going to be multiple times, and every time you calculate the interest, it gets added to the principal before the interest is calculated again. So the result is interest is being earned or charged on interest. So it's interest on interest, which could be good if this is an investment, but could definitely be bad if this is a loan. So let me kind of try to show you how this works, okay? Let's just say we had a simple interest investment of $1,000 at 2% for a year. So remember our simple interest formula said interest is going to be equal to principal times rate times time. So in this case, we'd have $1,000 at 2%, that's 0.02 as our decimal, for a year, so our time would be 1. And that would be an interest amount of, let's just put this into our calculator, 1,000 at 2% for a year is 20 bucks. Okay, so that means at the end of the year, the total that you have, if let's just say this is an investment, okay, the total that you have is the $1,000 that you started with plus the $20 in interest, so $1,020. Okay, so simple interest, one shot. There's your fee, or there's the amount that you're going to earn, depending on if it's a loan or an investment, okay? With compound interest, we're still calculating interest technically the same way. It's principal times rate times time, but instead of just a one-time shot, you're going to be calculating the interest multiple times for the year. So let's say that we have this $1,000 investment at 2% again, and it's still for a year, but instead of calculating the interest once, we're going to calculate it twice, and we call it compounding that interest twice. So if we were going to do it twice in the year, it's going to be in equal increments. So that would be after 6 months and then after the next 6 months. Okay? So every 6 months. So what's going to happen is, again, we have interest equal to our principal times our rate, 0.02 times our time. Now the first time, since we're going to do this twice for the year, it's going to be after 6 months and then after another 6 months. So our time is going to be 6 months. Now remember, that's 6 out of 12 months for the year. So we could put a half there. I'll just keep it as 6/12. And so the interest over the first 6 months, let's go ahead and make this 6 out of 12, is going to be $10, okay, which makes sense, right? That's half of what we had before. So we end up with $10 here. Now, before we calculate the interest for the second 6 months, that $10 interest gets added into the principal amount. So on the second round here, our interest is going to be on a new principal, which is $1,000 plus the 10, so $1,010. And we're still at 2%, and now we want to know what's the interest going to be for that next 6 months. Okay, so for the next 6 months, again, this is going to be $1,010 now. Now we have $10.10. So the interest earned is here is $10.10. So what do we have now total at the end of this year? So the total now is we were at $1,010, right? And sorry, we were at 1,000, then we got $10. Let's do it from the beginning. We were at 1,000, we got $10 for the first 6 months, and then we got $10.10 for the next 6 months. So the total here is 1,020 and 10 cents. So the total here is more than the total here because that second time we calculated the interest, we were calculating it on the original principal plus that interest that got added in for the first 6 months. Now, 10 cents doesn't seem like that big of a deal, but the larger your investment, the larger your rate, and the more times you compound or calculate that interest, the bigger the effects are going to be. Okay? Now, if we wanted to, let's say, compound the interest daily, it would require us to use our simple interest formula 365 times and each time add that interest in. That would be a bit ridiculous. Okay? So, the math powers that be, not me, okay? But the math powers that be have established a formula that will calculate this compounded interest for us as long as we know the principal amount, right? What is the rate? What is the time for the loan? Those three things are the same. But if we know how many times we want to calculate the interest over the year, then we can use this compound interest formula, okay? But the idea behind it is simple interest, just multiple times throughout the year. And again, the idea is interest is now being earned on the principal and the interest. So here is our formula. Our formula says that A is equal to P times 1 plus R over N raised to the NT power, where A in this formula represents the total amount that you're going to have at the end of your investment or your loan. So it's the total final amount. Actually, I'm going to put that in there. The total final, it's like redundant, but I just want to make sure you understand it is the total amount. Because in the simple interest formula, all it's calculating is the interest. You have to go back by hand and add that into the principal to get that total final amount. Okay? P still represents the principal. So it's the starting amount, the original investment, or the original amount of money that you borrow. R is still a rate, and it will be, again, given as a percent, but we want to plug it in as a decimal or a fraction. T is still a time. And now for our simple interest formula, that time has to be input in years. So if we have a time that is not given in years, it's going to have to be converted. And then N is the new piece in our formula, and N is the number of times. It is the number of times that we're going to be compounding or calculating that interest. So if our problem says that we're going to be compounding annually, annually means one time per year. In that case, we might as well just use the simple interest formula. But annually means N would go in as 1. If it was monthly, N's going to go in as 12 because there are 12 months in the year. Semi-annually would be 2. That would be 2 times per year. Weekly would be 52 weeks in the year. Quarterly would be 4. That's 4 quarters in the year, 4 times per year. And then daily is going to be 365 because there are 365 days in a year. Okay, I think those are the only options that we would see. If something else comes up, I'll throw it out there, but I believe that's all we're going to see. Okay, so again, just to reiterate some of the connections between simple and compound interest. So simple interest is our interest formula, and it calculates just the interest. Okay, calculates just the interest, where our compound interest formula has all of this, and it calculates the total final amount. All right, so there's one difference. And with simple interest, we're calculating interest just once over your time period. And with compound interest, it's n times. So 4 times, 365 times, 52 times, whatever it is. And so the result of that is, with simple interest, you're only accruing interest on the principal. Whereas with compound interest, you're accruing interest on the principal and the previous interest earned. Okay, so those are the basic differences there. Now, let's practice calculating some compound interest. So, for example, number 1, it says that you invest $4,000 at 8.25% compounded semi-annually. How much will you have total after 5 years? How much will you have total after 5 years? So, 4,000, that is our principal beginning amount there. 8.25% is our rate, And 8.25%, remember, means 8.25. That's really squishy. Sorry, 8.25% means 8.25 out of 100, and so that would be 0.0825 as a decimal. When it says that interest is compounded semi-annually, that means twice per year, so we're going to be putting in 2 for n. And it says, how much are you going to have total? Total means we want to find that total amount after 5 years. So 5 years, that is our time. Okay, so our formula says A is going to equal P times 1 plus R over N raised to the NT power. So in this case, A is going to equal our principal amount of 4,000 times 1 plus our rate is going to be 0.0825 over n, which we said was going to be 2 because it was semi-annually, and that's going to be raised to the nt power. It's n times t power. So that would be 2 times 5 there. And I'm going to use parentheses just so that dot doesn't look like a decimal. Okay? So that's the hard part, making sure we've got everything into the formula correctly. So now we input into our calculator. Get rid of all this nonsense. All right, so 4,000. And then parentheses 1 plus 0.0825 divided by 2. And then we got to get out of the fraction, close the parentheses, and we're going to raise it to a power. And I want 2 times, oops, I'm going to have to put parentheses. I want 2 times 5 in that exponent. And there it is. And because this is money, we're going to round to the hundredths place. So $5,992. And 53 cents, because after the 2 is an 8, we would round that to a 3. So there it is. How much total are you going to have? If you start with a $4,000 investment at 8.25% compounded semi-annually after 5 years, you're going to have $5,992.53, which, by the way, means the difference there, the $1,992.53 that it's grown is in interest. Okay, in interest was earned. That's $2,000 in interest. That's pretty decent. Now, good luck finding a place that's gonna earn you that high of a percent of interest. But if you could, then by all means. Okay, so the answer here was this guy, the $5,992.53, but just so you're aware, that's the difference between what you started with and where you ended is how much interest was earned. Okay? All right, let's try that again. So it says for number 2, you have you invest $5,600 at 7.5% interest for 3 years. How much interest will you have earned after 3 years if interest is compounded daily? So I can't underline, it's all squished in there. Our principal amount is given to us is $5,600. It says the interest rate is 7.5%. So that would be 7.5 out of 100, which would be 0.075 as our decimal. It says for 3 years, so t is 3. And it says, how much interest are you going to have earned after 3 years if it's compounded daily? So daily means n is going to be 365. All right, so these are the pieces we have now to figure out what our final amount is going to be. So let's do that first. So A is going to equal 5,600 times 1 plus 0.075 over 365. And then we're going to raise that to the 365 n times t power, so times 3 power. So that's going to give us a final amount of, let's see, 5,600. 1 plus 0.075 over 365. Raise that to the, in parentheses, 365 times 3. And we end up with $7,012.85. Okay? So be careful. If you're working on your practice, make sure you're reading the question carefully. This time it says, how much interest are you going to have? So the $7,012.85, that's the total amount. Okay? This is the total. The total amount you ended up with. So if you started with 5,000, or it's 5,600, you want to subtract that out to figure out the interest. So let's take that and subtract 5,600. And so $1,412. $1,412.85. Duh. In interest. Okay, so that's going to be the answer for that one. All right, so you can use that to find the total final amount and then subtract out the principal amount if you're asked for the interest. Now there's another formula introduced here. It's called the present value formula. It should look a little similar to the other one. So let me just show, oops, sorry, don't freak out. We're not doing logarithms. So our compound interest formula says this. We can use this to calculate the final amount. So if we know principal rate, we know a number of times compounded time, if we know all these variables, then we can solve for A. We can figure out what that final amount is. Now, if, let's say, we wanted to work in reverse, let's say I knew that I had this savings account that was going to compound 3% interest for 10 years, and I wanted to save up a total of $20,000 at the end of that 10 years. I could use this formula to figure out that principal amount that I would need to get to the final amount. So if I wanted this to be solved for P, remember we were solving literal equations, right now P is being multiplied by this whole thing. So if I just divided both sides by that whole thing, if I divide that mess over, and divide this side by the same thing, 1 plus r over n to the nt power, it would cancel from that side, and then P would equal a over 1 plus r over n to the nt power. It's the same formula, it's just rearranged. This version of the formula is helpful to solve for or to find the final amount. This version is more helpful if we want to find the present value that we need to get to that final amount. So when it's in terms of A, we would leave it in terms of A, or want it in terms of A if we're going to find the final amount, but we want it in terms of P if we want to find the principal amount or the present value. Okay? So this is solved for P in terms of P. Okay, solved for P or in terms of P, and this is for finding the present value or principal amount. Okay, for finding, we call it the present value, but it's the principal amount. Present value or principal amount. And the other version that we had on the front here, this one is solved for A, and this one is for finding the final amount, right? This is solved for A. This is for finding the final amount. So the purpose of, remember, the literal equations is be able to manipulate formulas to put them in terms of what we need for our problem. So if we were doing a bunch of problems where we had to find P instead of finding A, we would want the formula to be rearranged. Okay? So let's look at an example. So for number 3, it says, how much should you invest at 12% compounded quarterly for 20 years to reach $25,000? So again, in this case, I am looking for how much to put in. How much should I invest now? I don't know. What is that principal amount? 12%, so that's 12 over 100, or 0.12. It's going to be compounded quarterly, which means n is going to be 4 for 20 years. So t is going to be 20, and we're trying to reach a final amount, A, of 25,000. Okay, so you can see how that would be helpful. If you know the terms of an investment and you know where you're trying to get, then you can figure out how much you got to put in now to make that thing happen. So P this time is going to equal A, which is 25,000, divided by 1 plus r over n raised to the n. Did I put? Yeah. Oops. Writing this variety waves. N times t, so 4 times 20th power up here. And it's just a matter of going to the calculator. So we've got 25,000 divided by, in parentheses, 1 plus r, which is 0.12 over n, which was 4. Close that and raise it to the, in parentheses, 4 times 20th power. And we're looking at $2,349.43. Okay, so that is the amount that you would have to put in now if you could just plop down $2,349.43 and let it sit there in this account or investment that's earning you 12% compounded quarterly. Let it sit there for 20 years. You're going to have 25 grand saved up. Now, I don't know how reasonable it is to be able to find an investment option like that or to be able to plop down $2,300, but there it is. Okay? All right, let's try one more. And if by all means, if you're feeling comfortable with this and you want to try on your own, then give it a shot. This one again is saying how much should you invest, meaning you don't know the principal or starting amount, at 7%. So our rate is 7 out of 100 or 0.07, compounded monthly, so n is 12, for 15 years, t is 15, to get to a final amount, reach a final amount of $12,000. So p is going to equal 12,000 over 1 plus 0.07 over n was 12, raised to the 12 times 15 n times t power, and it's calculator work from there. So 12,000 divided by 1 plus 0.07 over 12, and then raise that to the 12 times 15 power, and we have $4,212.08. So again, if you had $4,212.08 to plop down into this account to invest into this investment, whatever it is, and the interest was at a rate of 7% compounded monthly for 15 years, that investment would grow to $12,000. That's a lot of interest, right? If you get to 12,000, think about that, right? If you had 12,000 at the end there, can I move my cursor? Let's just say minus 12,000. So the difference, that's 77, that's $7,787.92 in interest, right? That's a lot of money in interest, okay? Or up here, we started with 2340, or we start with 2349.43 to get to 25 grand. Where's that one at? Let's subtract out that 25 grand. And that's here. Oops, let's change colors. That is $22,650.57 in interest. That is a lot of interest. Okay, so it seems like a lot of money to have to plop down, but I mean, think about how much you're getting in interest just for letting your money sit there. Okay, so I think you have the tools necessary to get started on this practice, but as always, if you need some extra help, then just reach out. All right, guys, take care.